There, Mr. Sutton here, bringing you the Algebra 2 Honors 2-1 homework solutions on transformations of quadratic functions. For this problem, we're trying to graph this transformation of x squared. So first off, let's figure out from this formula what's going on. Since we are subtracting 3 outside, that means that we have a vertical shift of down 3. So that's the first thing to keep in mind. Let's now take a look at the parent table for x squared. So that was -2 through 2, 4, 1, 0, 1, 4. This is our standard parabola. And let's see what happens if we transform that now to get the g function. So since this is an outside change, we're not doing anything to the x values. The horizontal is staying the same, so we're just going to keep x the same for everything here. But for the y values now, if you're shifting down 3, you have to do y minus 3 for every point on this graph. So now for the x's, we've still got -2, -1, 0, 1, and 2. For the y values now, let's subtract 3. So 4 minus 3 is 1. Then we have -2, -3, -2 again, and 4 minus 3 hasn't changed. That's still 1. Let's graph all this out now. So we've got -2, comma 1, -1, -2 is down here. 0, -3 is right there. Then we're up to 1, comma -2, and 2, comma 1 right there. And we graph the parabola through those. For this problem, this x plus 2 squared is going to be a translation of x squared. Since it's inside, it's going to be a reverse of what it looks like, and it's a left-right deal. So adding 2 inside really means we're shifting left 2. So let's set up our parent table. There's our quadratic parent function table right there. And then for the g function, since we're shifting left 2, that means the x values actually have to get subtracted by 2. So we got x minus 2 for that new rule. And we're not doing anything vertically. There's no outside changes here, so y just stays the same. So subtracting 2 from all the x's, we've got -4. -1 minus 2 is -3. This will be -2. 1 minus 2 is going to be -1, and then 2 minus 2 is 0. So new x values. For the y values, those haven't changed, so we still have 4, 1, 0, 1, and 4. Graphing all those out now, we've got -4, comma 4 up there, -3, comma 1, -2 zeros right there. Then we have -1, comma 1, and then 0, comma 4. And graph the parabola. For this transformation, we've got addition and subtraction, so this is all translations, all shifting. The +6 inside means we're actually shifting left 6. The -2 outside means we're shifting down 2. So here's our parent table for the quadratic. And for the g function, the new rule for x, left 6 means we have to do x minus 6. And then shifting down 2 means we've got y minus 2. For the x's, just subtracting 6 from all of these, -2 minus 6 is -8. Then we have -1 minus 6, so -7. Then we've got -6. 1 minus 6 is -5. And 2 minus 6 is -4. For the y values, we got 4 minus 2. 1 minus 2 is going to give us -1. 0 minus 2 is -2. And then we have -1 and +2 again. For the graph, we've got -2, comma, or -8 rather, comma 2. -7, comma 1, or -1 down there. And then -6, comma -2, there we go. And then we have the symmetrical part of it, -5, -1, and -4, comma 2. And there's your parabola. For this transformation of f of x equals x squared, we have a 2 outside the x squared, so that's a vertical stretch by 2. So here's our parent table for x squared. And then we've got the g function now. Since I'm doing vertical things, I'm not doing anything to the x value. So x is just going to stay x, whatever it was originally. For the y values, we're going to be multiplying y by 2 because of this vertical stretch out here. So 2y for that rule. So for the x's, I've still got -2, -1, 0, 1, and 2. And for the y values, I just have to double all these. So 4 becomes 8, 1 becomes 2, 0 is still 0, and then we have 2 and 8 again. Let's go ahead and graph this now. So we have -2 comma 8 right there, and then -1 comma 2, 0, 0, 1 comma 2, and 2 comma 8. And then there's the parabola going through those. On this problem, we're doing a few transformations to the x squared function. So this negative outside the squared stuff, that's a vertical change, a vertical reflection. And then the 2 inside is giving us a horizontal, so it's reverse of what it looks like. So we're not actually multiplying x's by 2, we're actually shrinking. So this is going to be a horizontal shrink. So for the parent table, there's the x squared parent table that we're used to dealing with for quadratics. Now for the g function, since we're shrinking horizontally, we're not multiplying by 2, we're actually dividing by 2 or multiplying by the reciprocal of this, 1/2. So I'm going to write 1/2 x for that rule. And then I'll write -y to give us that vertical reflection. So for the x's, we're multiplying each of them by 1/2. -2 becomes -1, and then -1 is -1/2. 0 is still 0. We also have +1/2 and +1. For the y values, we're just going to negate all of the originals. So -4, -1, 0 is still 0, -1 and -4. Graphing all these out, we've got the point -1, -4 to start us off here, so that's down there. And then we have -1/2, -1 right about there. 0, 0, 1 comma, let's see here, no, 1/2 comma -1, there we go. And then over here we've got 1 comma -4. And we have our first upside down parabola of this problem set. For this one, we've got a whole bunch of transformations happening to x squared, so let's go through them one at a time. This -2, let's take a look at that first. That's outside the x squared, so these are vertical changes here. There's 2 changes. The negative gives us a vertical reflection. The 2 gives us a vertical stretch. So we have a vertical reflection and stretch. Now we're also adding 1 inside and subtracting 2 outside. Those are both going to be translations. Again, the inside stuff is reverse of what it looks like, so this is actually a left shift of 1. And outside is exactly what it looks like, so this is actually a downshift of 2. So we're going left 1, down 2. Here is our x squared parent table with -2, 4, and all the rest of those. And now for the g function, for the new rule for x, the only thing happening horizontally is that we're shifting left 1. So x minus 1 is all we have to do for the x values. For the y values, we have multiple things happening. And this -2 is going to have to happen first because multiplying happens before any other operation that's here. So we have -2 times the y value, and then we will have to subtract 2 from that. So -2y minus 2 is going to be our rule for this one. That gives us the reflection, the stretch, and also the shifting. Going back now and taking care of my x values, we're just subtracting 1 from all these. So -2 becomes -3. And then we have -2, -1, 0, and 1. So we've literally just shifted everything 1 to the left. Now for the y values, a bit more going on. -2 times 4 is -8, minus 2 is -10. -2 times 1 is -2, minus 2 is -4. -2 times 0 is still 0, minus 2 is -2. And since we're plugging in 1 and 4 again, we're again going to get -4 and -10. So that's nice to not have to redo all of that in our heads. All right, let's graph all this. So we've got, and now look here, I actually made my grid lines go by 2's vertically so that I can fit these 10's here. So we've got -3, comma, -10 down here, -2, comma, -4, and -1, comma, -2 is right there. Then we have 0, -4, and 1, -10. and there's the parabola on this one. For this one, we are trying to write the rule described by the transformations of the graph of f down here, and then identify the vertex. So we're doing a few things: a vertical stretch by a factor of 4, a reflection in the x-axis, and then a translation of 2 units up. So we're going to take these one at a time, writing a new function for each of them. Let's start with the vertical stretch by 4. So that's just going to be 4 times whatever the f of x function is. So I'll write g of x equals, actually we also have a reflection in the x-axis. We'll make that -4. We'll just do it all at once here, I guess. And then that's going to be -4 times x squared. So that's the g function. Now we also need to translate 2 units up. So I'm going to write an h function that's going to be the g function plus 2. That'll give us that translation of 2 units up. So this then is just going to be -4x squared plus 2. And that's our new rule. Now for the vertex on this is in vertex form, although it doesn't look like it. This x squared is really like an x minus 0 parentheses squared. So our vertex then is going to be 0, comma, positive 2. For this problem, we're starting with the rule f of x equals 8x squared minus 6, and we're doing a horizontal stretch by a factor of 2, a translation 2 up, and a reflection in the y-axis. Whole bunch of things. So I'm going to make a new rule for each of these transformations, and we'll just take them one at a time. So I'm going to make a g rule that stretches this thing horizontally by 2. Now to get a horizontal stretch by 2, that means I have to multiply x on the inside of the function by 1/2. It's reverse of what you think it would be, since it's an inside horizontal change. So I'll write g of x equals f of 1/2 x. So actually applying that here, that's going to be 8 times 1/2 x squared minus 6, like so. And let me do the exponent first now when I simplify this. So 1/2 x squared is really 1/4 x squared. 8 times 1/4 is 2, so this is 2x squared minus 6. So all this is doing is that horizontal stretch by a factor of 2. All right, next up, let's do that translation of 2 units up. So I'm going to take the g function now and make an h function out of it by doing g of x plus 2. Since it's a vertical change, that has to happen outside the function. And then g of x was just this 2x squared minus 6. So I've got 2x squared minus 6 plus 2. That's just going to be 2x squared minus 4. And then finally, I need to reflect this thing in the y-axis. So I'm going to create a j function. And j is just going to be h of negative x. If I want a horizontal reflection, I have to negate the x in there. So I'm going to have then 2 times negative x squared minus 4. But if I square negative x, I just get positive x squared. So this is still just going to be 2x squared minus 4. Horizontal reflections of things that are already on the y-axis, like this h function is, don't actually give you a real change. Now for the vertex on this, again with this x squared, we've really got x minus 0 quantity squared, so that's 0 for the x value, and then this minus 4 gives us minus 4 for the y. So 0 comma negative 4 for that vertex.